Hey everybody, it is Mr. Odom, and I am going to take a few minutes to go over the Chapter 9 practice test answer key. All right, remember to use this to help you study, and when you're taking the test, make sure that you have this available. So if you need to go back and look and see how a problem is solved, especially in how to show your work, which you're going to have to do for some of these problems, then um, you'll see how I do it. And that's what I'm looking for you to do as well. Okay, let's get started. So, number one, find the surface area of the prism. I label the length, width, and height, and then I use the formula for surface area. I plug in the numbers and I get my answer. Problem two, find the surface area of the prism. What do? I use the formula, area of the bases plus the area of the lateral faces, and you see that right here. And I come over here and I calculate the area of my bases. I look at one of the bases here. I find the area of it here, and then I multiply it by 2. Why? Because there's two bases. There's one down here and one up here. And then for the lateral faces, this is a triangular prism, so you always have 3 rectangles. So I find the area of all 3 of these, okay? And then I'm going to leave it to you to add all these together. Well, actually, I won't leave it to you. We can add them together. So what do we get? Surface area equals 24 plus 60 plus 50 plus 50 plus 160. So the surface area is 184 centimeters squared. Okay, there you go. Next. Well, wait, it's right down there. I did do it. Okay. Moving on. Use the net to find the surface area of the regular pyramid. Pay attention to this problem when you see it. They give you the area of the base. All right. So they give that to you. And then so you have to find the area of the lateral faces. How many lateral faces are there? There are 3. That's why when I find the area of one triangle, I multiply it by 3 to get my lateral surface area. And then I just add it to the area of the base and I get my answer. Find the surface area of the square pyramid. There you go. The area of the base. So this is a pyramid, so there's only one base, and it is a square. You can see that this is a square. So I find the area of that, and then I find the area of the lateral faces. So I find the area of one triangle, and I multiply it by 4 because there are 4 of them. And then I just add them together, and I get my answer. Find the surface area of the cylinder. Round your answer to the nearest tenth. Don't forget to round your answers correctly. There's my formula. There's my work. Okay. Notice my answer is rounded to the nearest tenth. And also notice that I did not just multiply by pi up here in this part of the problem. I leave it until I get to the end. So I treat pi like a variable. Okay. So I have 60 times pi feet squared, and my calculator multiplies 60 by 3.14, and that's how I get my answer. Which value is closest to the lateral surface area? So I need to remember that the lateral surface area, the formula for it, I don't care about the area of the circles, just the lateral surface area. So there's my work, and I can see that 251.2 feet squared is the value closest to the lateral surface area. Number 7, order the solids by volume from least on top to greatest on bottom. Well, I need to find the volume. So I find the volume of the rectangular prism. I find the volume of the triangular prism. And I find the volume of the pentagonal prism. Okay, so the one that should go on top should be the triangular. So this one would have to get moved here. And then the rectangular would be moved here, and the pentagonal has the largest, so that one stays on the bottom. All right, so make sure you find the volume of all three of these, because your pentagonal prism, that one may be on top or in the middle. Okay, so don't just go to this problem and say, okay, well, in the practice test, the triangular prism was on top. It may not be that way on your test. Find the volume of this pyramid. All right, I used the formula right here. Boom. Capital B, I work that out down here and I get an answer. And then I just plug it in. And the height of my pyramid is 9 centimeters. And I just work it out. Volume equals 72 centimeters cubed. All right, for these problems, I'm just gonna, can you pick out the triangles that you see here? Yeah, this one is gonna go up here. This one's gonna go over here. Now it's gonna go over here. All right. The intersection, so there's a circle, so that one goes there. Rectangle goes there, and the triangle goes there, right? So make sure that you're paying attention to these. You should get them correct. Number 11, compare the dimensions of the prisms. Well, I found the dimensions. Here's the dimensions of the blue one. Here's the dimensions of the green one. And I want to know how many times greater is the surface area of the green prism than the surface area of the blue. So this is the ratio that I want to put together, green to blue. And so I do that, and I do the math, and I get 6.25. So the surface area of the green prism is 6.25 times the surface area of the blue prism, or 6.25 times greater than the surface area of the blue prism. All right, next, number 12. Wait, there's nothing there. Oh, it's scared me. Okay, so I have this regular triangular pyramid. All right, so that means what? It has a base and lateral faces that are congruent equilateral triangles, which means that the area of all four of these triangles is exactly the same. It has a lateral surface area of 57 square meters. So if I call this my base, I call that my base, that triangle has the same area as the other three. And the other three triangles, this one, and the one in the back here, make up the lateral surface area. So the area of those three triangles is 57 square centimeters. Well, since they are all congruent, they are all the same, you can find the area of one of the lateral surfaces, or one of those triangles, by taking the lateral surface area divided by 3. Well, since all four of these faces on this pyramid have the same area, then I know the area of my base, okay? And then I use my formula to find the surface area of a pyramid, area of the base plus the area of the lateral faces, and there you go. All right. Oh, by the way, let me go back one. So this is a problem. This is one that you're going to have to show your work for on the test. So I'll put a check mark by it. All right. This was another one. Okay. You're going to have to show your work for this one on the test. All right. This is another one. All right. So cylinder A has a radius R and a height H. So there you go. I write down the surface area for this cylinder. Cylinder B has a radius of 2r, so my radius equals 2r, and my height equals 2h. Okay, so that way I can put them in the formula, right? So 2 pi times the radius squared, well, my radius is 2r, so I put that there. My height is 2h, so I put that where h would go, and I put my radius here, right? Because my surface area formula is 2 pi times radius squared plus 2 times pi times the radius times the height. So I go from here to here. I'm just going to clean this up a little bit. So I end up with the surface area of cylinder B down here. And it would be nice if I could make this formula look similar to this one. And I can if I factor out 4. So I do that. And when I do that, then what's left inside of here in the parentheses is just the surface area of A. So I can tell that surface area of B, I make another ratio where I put the surface area of B over the surface area of A, and it equals 4. So that means the surface area of B is 4 times greater than the surface area of A. All right, so that's one you'll have to work out. Number 14, choose the statement that best describes the error in finding the volume of the solid. All right, so there's the formula, right? Actually, the formula for the volume is volume equals area of the base times the height. So I come down here to calculate the area of the base, right? And what did we forget to do here? We forgot to divide that by 2, right? So that is my error, okay? So, or you can think of this as saying, oh, dividing by 2, that's the same thing as multiplying this by 1/2. Okay, so don't forget that. All right, so there you go. Number 15, compare the volume of the prism to the volume of the pyramid. All right, so we can find the volume of the prism. I know my length, my width, my height. So there's the volume of that one. I can find the volume of the pyramid. Here's my base. I can find the area of that base. It's 3a times 3b. The height of my period is 3c. One of these threes cancels. So I do the math, and this is 9 times a times b times c. So the volume of this is 9. The volume of this pyramid is 9 times more than that. Okay. Another way to think about this volume is less, the volume of the prism is less than the volume of the pyramid. So basically, you're going to calculate these volumes and compare them. Number 16, this is one you're going to have to show your work for. All right, so let me find the volume of the composite solid. You need to pay attention. Yours might say find the surface area. This one says find the volume. All right, so I find the volume of this pyramid. I do the work over here, and I get my volume. I find the volume of my rectangular prism down here, and I get the volume. And then what do? I add those together. Okay, so my answer is 80 cubic centimeters. Number 17, this is one you'll have to show your work for. So I have my 2 square pyramids. I want to know how much more sand is in the pyramid with the greater volume. Well, which means I need to calculate the volume of each one. So I do that. Here's the volume of the first pyramid. Here's the volume of the second pyramid right here. And here's the volume of the first pyramid right here. This one is the greater one. So I want to know the difference between the two so I can figure out how much more sand is in this pyramid than this one. So I do that work right here. Okay. So you're going to have to do that on your test. Number 18, we're almost there. This is another one you have to show your work for. So this is the one that I gave you for homework. I had the golf ball box. Okay. So we have this white label that's wrapped around a rectangular box. So, and this covers 80% of the lateral surface area of the box. Okay, so let me calculate that lateral surface area of the box. So I do that. My lateral surface area of the box is this, 12 times x inches squared, because there's my length, my width, and my height. Let me calculate the surface area of the label. Okay, so I do that, and I use this formula for the lateral surface area, and I have the lateral surface area of the label equals 72 inches squared. And this is the part. This lateral surface area of the label doesn't take up the entire lateral surface area. So that's the part. The lateral surface area of the box is the whole. And here's my percent. Okay, so I go back to chapter 6. I use the percent equation. I plug in what I know, and I solve for x. So x is 7.5 inches. Number 19, this is like the Ottoman problem, a little bit like that one. So again, another whole part, we got to find the percent. So I have a layer cake. It's got vanilla and chocolate frosting. I'm starting to get hungry here. What percent of the surface area of the cake, not including the bottom, so don't include the bottom when you're calculating surface area. So how much of this surface area is chocolate? Okay, so we can find the surface area of the cake, not including the bottom, which means there's a circle down here that I don't include in my formula. So that's why it's not 2 times pi times radius squared. It's just pi times radius squared, because I'm only concerned about the area of that circle. Okay, so we figure out the entire surface area of the cake. And then I can figure out what's the surface area of the chocolate, which would be my part. I would be eating that part. So the surface area of the chocolate is just the lateral surface area. And I have the height right there. It's 2. And I have the radius, which is 4. So I calculate the surface area of the chocolate. And then again, I go back to chapter 6. I use the percent equation, and I can solve for P. So I end up with P equals 1/3, and you should remember how to turn that into a percent, how to turn a fraction into a percent. All right, and it's rounded to the nearest tenth of a percent as well. Last problem, the problem that worked on in class, the fuel tank problem. This one, it's 40% full. Well, then how empty is it? 60%. So that's the amount of volume I want to calculate, the empty part. So I can find the volume of the rectangular prism, and I can take 60% of it by multiplying the volume by 0.6, which means I need to multiply 0.6 times the length times the width times the height. But wait, the units here are feet. The units here are inches. And I know someone is going to put 2.75 in here and 1.5 in here and 7. They're going to forget that I need to have the same units. My units are going to be inches. So over here, I turn the feet into inches using unit analysis. Okay, so 2.75 feet, this is 33 inches. The feet cancels there. Down here, the feet cancels. This is unit analysis, so I get 18 inches. So then I put those numbers in here into the formula, and I get, well, here's what 60% of the volume of the tank is. And then I have to use this conversion. I do my unit analysis again. I want to turn inches into gallons, so I multiply the volume by this conversion, where I can cancel, and my answer will be in gallons. Okay, so you're going to have to do this problem too. All right, so hopefully that was helpful. I enjoyed working through that with you guys. And this is Mr. Odom, and good luck on your test. I am out.